Okay, next question. What is a limiting reactant, and how do you determine which reactant is the limiting reactant? I think I just described that, didn't I? Okay, the way that we do it in here is to you just perform a stoichiometric calculation from each reactant to, let's say, to find the amount of product you're seeking. The calculation that gives you the least amount of product will start with the limiting reactant. So that's how you find it. So this is actually the part of the question, the second part of the question. The first part of the question was, the first part of the question, number 18, was what is a limiting reactant? A limiting reactant is the reactant species that runs out first and stops the reaction. Now you may have your answer written a little bit differently, but that's okay. You done already? Yeah. Okay. I think the text has it a little bit differently than that, but this means the same thing. Okay. What other questions do you have? What now? I'm not going through all those like that. Yep. Yeah. Why don't you leave your cell phone at your desk? Anything else? What? And that's a problem because, I mean, you know you're not black, but if you were, would it matter? Okay. All right. Okay. Now, if we turn on all the lights, you'd be black. So would I. Sure. With no light, everything's black.
Okay, I have a true question.
Anyway, yeah, let's go back to chemistry.
Why do people call them black? They're not black.
You're right, they're brown. Now, let's go back to chemistry. So, what other questions do you have about the practice test? 21. This is what we've been working on this entire unit, day by day by day. Evan, focus up here, please. Number 21. question states, you are performing the following lab procedure. 2 grams of calcium chloride and 1 gram of aluminum sulfate are dissolved in separate containers with 100 milliliters of water, which are then mixed together. Okay, this is different set of chemicals, but the same procedure you used in the most recent lab, if you did the most recent lab. Okay, a white mixture forms, and the mixture is allowed to sit undisturbed for 10 minutes. After sitting, it is observed the white material has settled at the bottom of the beaker, and the clear liquid remains in the beaker. Well, what that means is we have two reactants. One is calcium chloride, and it says it's dissolved, so we can be pretty certain that this is going to be aqueous. And you have to balance the formula. You need to know how to balance a formula. That was 2 units ago. Alright? So you look up calcium on the periodic table with oxidation numbers, and you'll find it has a 2+ charge. And you look up chlorine on the periodic table with oxidation numbers, and the only negative charge you have available is a -1. So to make this neutral or 0 charge overall, I've got to have 2 of these to balance the 2+ charge on the calcium. So that's how we balance that formula. And then we're going to have aluminum sulfate. Aluminum is an element. You look it up on the periodic table. It has a 3+ charge on the periodic table with oxidation numbers. Sulfate is a polyatomic ion, so you look it up on the common ions list, and you'll see that it has a 2 negative charge. If I have a particle with a 3+ charge and a particle with a 2 negative charge, the only way to get the overall compound to have a 0 charge is if I have 2 of these and 3 of these. And it says it's dissolved in water, so you can be pretty certain it's going to be aqueous. Now, it wouldn't be a bad idea if you double check that in your solubility rules, but you can be pretty certain of that based on the description. Okay? And it says a white mixture is formed. So one of our 2 products is going to be a solid. We don't know which one yet, but one of them will be a solid because it says it's got a white mixture that falls to the bottom. That's what a solid is. That's the formation of a precipitate. Okay? Now I have 2 2-part compounds. Calcium, the names kind of tell you that. Calcium chloride, 2 parts. Aluminum sulfate, 2 parts. So the 2 parts then switch partners. The front part always goes to the back part. So calcium goes with the sulfate, and the front part always stays in the front. So if it's in the front here, it stays in the front here. Balance the formula. Calcium's 2+, sulfate's 2 negative. So that's balanced. And then we're going to put the aluminum with the chlorine or chloride, and the front part stays the front part, so it becomes AlCl. Then I have to balance that formula. We just said that aluminum is 3+, chlorine is 1 negative, so I have to have 3 of these to balance this 1 aluminum, or charge balance the whole thing, so the compound ends up having a neutral charge. A 3+ charge particle and 3 1 negative charge particles will back cancel each other out, and so we'll have no charge overall. Now we need to figure out which of these is going to be solid. For that, you're going to need your solubility rules. Okay? So if I look at this formula here, I can find sulfates are listed right here. It says all sulfates are soluble. Okay? If there's water around, and these 2 compounds says there's aqueous, the problem itself says they're dissolved in water. If there's water around, things that are soluble will be aqueous. Okay? But calcium sulfate is one of the exceptions. So if most sulfates are soluble and therefore aqueous, but calcium sulfate is not, then this must be what? Solid. Alright, let's find out about aluminum chloride. Aluminum is not mentioned in the solubility rules, but chlorines are. All chlorides, bromides, and iodides are soluble. So if there's water around, it's going to be aqueous unless it is an exception. Well, this is aluminum, and these 3 exceptions, silver, lead, and mercury, is not one of the exceptions. So this is going to be what? Aqueous. Okay, chlorides are soluble. The exceptions are when chlorine is bonded with silver, lead, or mercury. That's not silver or lead or mercury. So this must be aqueous. Soluble compounds are aqueous if there's water around. Okay? Alright, so now we know what the solid is. And if we further continue to read the problem, number 21, the clear liquid is decanted and the white material is filtered, rinsed, dried, and weighed. The amount of product recovered, well, which of these two things are we recovering here? Read the problem. A white material settles at the bottom. Clear liquid remains on top. The clear liquid is decanted and the white material is filtered, dried, rinsed, dried, and weighed. The amount of product recovered. What is the product then by that description? Yes, but that's also a it's the solid. Okay, so in this case, the solid is calcium sulfate. Okay, so that's how you identify what it is. You have to read the problem, read what you predicted. Okay, and you have to do a little. It's a solve a puzzle. It's not hard, but you got to figure out what's what. Okay, so that every calculation we do, at least in terms of finding the percent yield, that's going to be the product we're seeking right there. That's the only product we care about right there. Okay, that is the only product we care about. That's the one we're collecting. Now we still have to balance the equation. We haven't done that yet. So we're going to list all of our elements: calcium, chlorine, aluminum, sulfur, and oxygen. Make a kind of sort of mini spreadsheet or grid here. And then we're going to count everything. I've got 1 calcium. This subscript 2 means I have 2 chlorines. This subscript 2 means I have 2 aluminums. Now, this sulfate ion has 1 sulfur in the formula, but it's inside of parentheses with a 3 outside. So that 3 is multiplying everything inside. So the 1 sulfur times the 3 is 3 sulfurs. The 4 oxygens times the 3 is 12 oxygens. On the other side, we've got 1 calcium. We've got 3 chlorines. That subscript 3 beside the chlorine means I have 3 chlorines. I have 1 aluminum, 1 sulfur, and 4 oxygens. And what we want to do is to get both sides of this equation to have the same number of elements so that we are not violating the law of conservation of mass. Okay? So, let's see. We want to balance oxygen last in our rules. So we want to start, I suppose, with chlorine. Since I have 2 on the left and 3 on the right, I need a coefficient in front of both the species that contain the chlorine that will give us the same number of chlorines. This is a small whole number I want here. Okay, it can't be the same small whole number to get the same number of chlorines. What numbers do I put here and here to get the same number of chlorines on both sides? On which side? Left or right? Okay, I'll put 2 over here. And so what do I put over here? 3. That'll give us 6 chlorines on both sides. So that's going to change the number of calciums on this side, the number of chlorines on this side. Over here it's going to change the number of aluminums and the number of chlorines. And so we're going to recount now. So now I have 3 calciums. I had 1 calcium to start with, times the 3 gives us 3 calciums. I had 2 chlorines to start with, times the 3 gives us 6. Over on this side, I put a 2 in front of this species, so I have 1 aluminum there times 2, and that's going to be 2 aluminums, and the 2 times the 3 gives us 6 chlorines. Okay, so we unbalanced our calciums now. We've got to get the calciums right.